looking for a quick way to get up to speed on the cosmos. Today we're diving into a cosmic mystery, the hunt for hidden quasars. These are incredibly bright cores of distant galaxies, powered by supermassive black holes. They're basically cosmic lighthouses, really key for understanding how galaxies evolve.
Right. And for decades, astronomers thought, well, we'd probably found most of the really bright ones. But surprisingly, it turns out a whole bunch were actually missed by earlier surveys, which makes you ask, why? Why were these incredibly luminous things hiding?
Okay, yeah, let's dig into that.
Yeah.
So how do you find something that's been missed? This is where AllBRICQS comes in, right? The All Sky Bright Complete Quasar Survey. Their whole mission was to find these missing bright quasars using all sky data.
Exactly. And what's really neat is their method. It's quite elegant, surprisingly simple in a way. They use data from WISE, that's the infrared space telescope, and Gaia, which maps stars precisely.
Ah, okay. Heat vision and precision mapping.
Precisely. And they had 4 main criteria. For instance, they tossed out anything showing noticeable movement across the sky.
Because stars move like that, but distant quasars don't.
Exactly. Too far away. They also looked at mid-infrared color, basically how bright things are in specific infrared wavelengths. Active black holes heat up dust, giving this distinct glow.
The sort of heat signature that stars and normal galaxies don't have.
You got it. It helps filter out the noise. And their first study showed this worked really well. High purity, finding real quasars, and high completeness, not missing many.
Okay, so they had this refined method, then they pointed it specifically at the Northern Hemisphere. What did they find?
Yeah, this is where it gets really interesting. They followed up on 75 candidates with telescopes in South Korea and China. And get this, they confirmed 62 brand new quasars.
Wow, 62. Not just a handful.
Nope. And these aren't just faint smudges either. We're talking seriously luminous objects. Their brightness, the technical term is bolometric luminosity, ranges from, well, incredibly bright to astonishingly bright, among the most powerful things we know.
Like trillions of suns kind of bright.
Easily. Trillions. And their redshifts, how far back we're seeing them go from relatively nearby out to, much earlier in the universe's history. Redshifts from 0.09 up to 2.48.
And were there any specific discoveries that really stood out from those 62?
Oh, absolutely. One example is J1356 plus 3840. It turns out this is the most luminous FeLoBAL quasar found so far.
FeLoBAL. What does that mean?
It stands for Iron Low Ionization Broad Absorption Line. Basically, you see signs of iron being blown outwards in strong winds from near the black hole. These are super rare, maybe 0.3% of all quasars. So finding a really bright one is, well, it's a big deal for studying these outflows.
So like studying cosmic weather patterns from black holes.
Kinda, yeah. And how they impact the galaxy around them. There was another interesting one too, J0141 plus 7307, also showing strong iron features.
This discovery of so many bright mist quasars.
Yeah.
It must make you rethink existing catalogs, right?
It definitely does. We compared our findings to other big surveys, like Quaia and the Sloan Digital Sky Survey, SDSS, and while they missed a lot of these, Quaia, for example, sometimes had the wrong redshift, the wrong distance.
Significant errors then.
Yeah. And get this, 18 of our new quasars weren't even in the main SDSS quasar catalog, even though they were right there in the images SDSS took.
Really? Just completely overlooked.
Seems like it. It just highlights that even with these huge automated surveys, you still need dedicated, careful follow-up. Spectroscopy is key.
So bringing this all together, what's the main takeaway for you, for our listeners?
I think it really shows the universe still has surprises for us, even bright ones hiding in plain sight. And while these large surveys are fantastic tools, you absolutely need that precise follow-up, looking closely with spectroscopes to get the full picture. This new AllBRICQS sample, it's a goldmine for future research on how black holes grow and galaxies evolve.
It really makes you wonder, doesn't it? What other powerful, maybe even obvious cosmic objects are still out there? Just waiting for a slightly different approach, a new way of looking, to reveal themselves.